on your own. The proctor's not going to say anything else. The only thing the proctor can ask you is maybe like to clarify something. An example of that would be like, you know, what's the like thermal boundary of the home? And like, oh yeah, like the walls, the ceiling. It's like, what do you mean the walls, right? Exterior walls. So that would be something that the proctor would just be like, which walls?
Right.
Right. All right. So we're going to begin number 2, the exterior evaluation of the test house. So the first thing I'll do for this gated item is turn on all my diagnostic equipment outside of the home. While they're turning on and doing their thing, I can measure the perimeter of the house. Feet this way. 8 feet this way. So 24 plus 8 is 32. Multiplied by 2 is 64 linear feet. So again, linear feet of the house, the perimeter, not the area. Identify or discuss 2 basic exterior moisture control strategies or components. You have your gutters and you have your downspouts. Identify the exterior wall construction of the test house and discuss one other kind of exterior wall construction. So this isn't talking about the siding material, but this is a wood-framed platform house. Another type of building material or building type would be a balloon frame, or wood framed balloon style house, and that's where this wall studs are going all the way from the basement up to the attic. 2 other notes I need to check out here while I'm doing this exterior evaluation. I want to check the dryer vent. Oh, I put this here yesterday, no one noticed though. Put that in the dryer vent. And then I also want to look at the attic ventilation. We've got a gable vent on this side here. We have a soffit vent. And we have a roof vent up there. So this house has 3 different vent types. That concludes the exterior portion. Now we're ready for our interior safety evaluation. So I've got all this stuff. I'll put my CO monitor to my pocket. Clipboard, combustion analyzer, gas leak detector. Put my clipboard down, my pen. I can put my combustion analyzer right on the water heater.
Want to go peek in?
No.
Testing, is that on now? Great. Then I'm going to take just 30 seconds to walk around the house with my combustion gas detector and my CO monitor. I'm looking for ambient gas and I'm looking for ambient carbon monoxide. With my CO monitor, it's reading 0 parts per million. No actions required. It's safe for us to continue our audit. With my gas leak detector, it says 0 parts per million. That's less than 10% of the lower explosive limit. It's safe for us to continue our audit. Put the CO monitor back in my belt so I don't lose it. On the interior safety evaluation, number 3, locate 1 smoke detector and 1 CO detector. Here's our smoke detector. Back here, plugged into the wall, is our CO detector. Name 1 potential electrical hazard that can impact the work scope. Knob and tube wiring. Discuss 3 characteristics of radon. It's colorless, odorless, and radioactive. The primary health risk of radon is lung cancer. 2 potential sources Our entry points in the home for radon are cracks in the foundation or gaps around service pipes. Discuss how to detect radon in the home, where you can do a short or a long-term radon test. 2 conditions needed for mold growth would be moisture and a substrate or some material for the mold to grow on. 2 common areas of the home where mold might be found. It could be on the bathroom ceiling or underneath the kitchen sink. 1 potential health risk of mold is respiratory issues. 2 common building materials that might contain asbestos are siding and pipe wrap. 1 potential health risk of asbestos is lung cancer. Asbestos becomes hazardous when it's friable, when it can easily be crumbled and becomes airborne and makes our way into our lungs. 2 sources of lead in the home are paint and water pipes. 1 potential health risk of lead exposure is brain damage. And the appropriate personnel for lead testing procedures would just be a qualified lead professional. And that completes that interior safety evaluation part. Any questions about that? Again, except for those couple walking around with the CO monitor and the gas leak detector, so just reading everything off. Now we'll go to our combustible fuel leak testing, section 4. Name 2 fossil fuels, propane and natural gas. For each of these fuels, discuss 2 components of the delivery system. Well, for propane, we have our propane tank, and we have our distribution system, our distribution piping. And for natural gas, we have our distribution piping and the gas meter. 2 safety concerns about flexible gas lines or flexible connectors would be kinks, cracks, or corrosion. Okay, there's 3. And then conduct combustible gas leak testing for 1 to 2 minutes at least 3 fittings. At this point, I can swap over to this other page if I just need a refresher for that. Typically, you should start your gas leak testing at the exterior of the home at the gas meter or propane tank, and then follow the distribution pipe into each appliance. For this exam, we'll just begin right here. We want to keep the end of the wand within 1 inch of the pipe. We want to move no faster than 1 inch per second. For natural gas piping, we're going to test above the pipe. If it was propane, we would test below. To confirm suspected gas leak, we can use our gas leak detector solution. And wherever we do confirm a gas leak, we want to mark the location and notify the homeowner and let them know they should call a qualified professional to have it repaired as soon as possible. The field guide says to do 1 to 2 minutes and at least 3 fittings. You can't really go too slow, but you can definitely go too fast. So take your time. Let's see, so I took care of number 5, how to confirm a gas leak. State the actions required. Yep, mark the location, notify the homeowner, call the gas company to have it repaired. State the appropriate actions when fuel line deficiencies are identified. You want to make a note of it in the report, let the homeowner know that they should have it repaired by a qualified professional. Number 8, do a visual inspection of the oil supply system and identify leaks. If none are available, describe inspection steps and talk about 2 potential deficiencies. Well, a big deficiency would be an active leak from the oil tank, or if the fill cap is missing. Discuss the appropriate action levels in accordance with the NC BPI 1200. Wherever we do have a problem, we're going to mark the location, notify the homeowner, recommend repairs. Common theme again, that section. Let's see, we haven't really talked much about this next section, number 5. Doors and windows. For 1 exterior door, identify the material and operation type. So we'll come to this door over here. Right, so we've got our Yeah, thanks. Completely blanking. Right, we've got our metal door. What's the operation type? Well, for doors, it can either be like a sliding glass door or a hinged door. So this would be a hinged door. It's on its hinges. For one window, identify the operation type. This is a sliding window. The framing type, it's vinyl framed. Number of panes, double pane window. For one window, identify and discuss its compass orientation and exterior shading. So I get my compass out. The window faces north. There's no exterior shading present. For one window and one exterior door, determine and discuss the fit, operation, and general condition. So for this exterior door, it latches closed properly. It fully opens. Looks like all the weather stripping's present. No signs of rust, damage, or corrosion. Looks like it's a fairly new door. So this door appears to be in good condition. For one of these windows, the window closes properly. The lock slap's closed. No signs of moisture intrusion. Looks like a nice window in good condition. And for one window or door, measure its size. I'll go to the door here. Right, so this door, it's 32 inches wide. And 76 inches tall. And just like a real exam, I'm dropping stuff everywhere. All right, doors and windows are set. Any questions about that? We'll go over that after if we need to as well. So on to section 6, building components and construction details. Identify or discuss two locations of the existing thermal boundary. That would be our ceiling, and that would be our exterior walls. Identify or discuss two common thermal boundary deficiencies in basements, crawl spaces, and slabs. For insulation of the basement or crawl space, either it's missing, fallen down, damaged by moisture, or pests. It's 4 things. Discuss the function or purpose of a vapor control layer. The purpose of a vapor control layer is to reduce moisture transport via diffusion. Discuss the appropriate location of a vapor control layer. In our cold climate, it should be on the interior side or the interior face of the exterior walls. Two types of vapor control layers should be the craft paper on fiberglass bat insulation or plastic, formo poly. Identify or discuss 3 infiltration points and the location for each. Well, we could have air leakage around our recessed light, around our ducts going into the attic, and around our electrical outlets or the attic access. Discuss 2 common infiltration points from detached garages. Well, a big source would be the door itself, or maybe any receptacles or light switches on that wall. Identify the existing attic ventilation types in the test house. We already did that. We had the gable, roof, and soffit. Discuss 2 factors that can negatively affect attic ventilation performance. If they're blocked by insulation, or they're, when the vent was installed, the opening wasn't cut out to accommodate the vent wide enough. Attic inspection. All right, let's see, we're up here in the attic. Identify the dimensions and spacing of the attic framing members. So these are 2x6s, they're 16 on center. Determine the type of existing insulation. We have a small area with some fiberglass bats. Most of the attic has nothing. And for those fiberglass bats, they're about 4-inch bats. Our value for that would be about R13, and it's in poor condition. Recommend insulation for the entire attic. Then while I'm up here in the attic, I'm going to look at the air duct system. Says identify the HVAC distribution system type and describe its condition. Well, it's a ducted system, and most of it doesn't have any insulation. It doesn't look like any duct sealing has been completed on it. Looks like one of the flexible ducts at the far side, maybe slightly kinked. It makes a sharp bend. This one here is missing insulation, so I'd say the ducts are in poor condition. Again, if there's no insulation, so the R value would be 0. That's all that's needed for that section. And then for their bathroom exhaust fans, talking about the ventilation type, it has an uninsulated hose, and it's terminated right in the attic. So I recommend replacing that with an insulated hose that's vented to the exterior of the house. Exterior wall cavity, describe how to determine the insulation thickness and type, and identify framing member dimensions. Either I could drill a small hole and maybe visually see what type of insulation is there, or use a borescope if needed to see the insulation type. I can, if the hole's big enough, if I do it from the outside, maybe I can stick a tape measure in there to determine the thickness of the insulation. And then I can turn my tape measure from side to side to get the dimensions right. If it's 16 on center, older home it probably is. And the next one, describe how to safely measure the wall cavity depth. Again, at that point, I can drill a little hole, stick a wooden skewer in there, or non-conductive probe to determine the depth of the wall cavity. Building, airflow, and mechanical ventilation. All right, so number 1, it actually says identify or discuss 2 kinds of whole house mechanical ventilation. Cross out whole house. And we'll do that in the classroom too, but all it should just be is identify or discuss 2 kinds of mechanical ventilation systems. This is easy. There's exhaust only, there's supply only. That's 2. Discuss one way that mechanical ventilation might affect building infiltration or exfiltration. Well, if I'm turning on my bathroom exhaust fan and it's sucking air out of the house, it's going to be replaced with air from the outside, so I'm going to have air leaking in. Identify one existing mechanical ventilation type over in our bathroom. We have our exhaust fan in our bathroom. Identify the type of control for one existing exhaust ventilation fan. Well, it's a manual switch as opposed to like a timer or some sort of sensor. Access the condition of the ductwork for an exhaust ventilation fan. I already did that in the attic. Discuss 2 factors that can negatively affect ventilation system performance. If the exhaust hose is either blocked or excessively long, or it's kinked. And then measure the flow rate of one local exhaust ventilation fan. Turn my manometer on. I'm going to go to tubing assistant. I'm going to scroll all the way over to the right, other applications, exhaust fan meter. Tells me how to set up my hose. Hit continue. I'll go over to the bathroom. Turn the fan on. Make sure my hose is set up correctly for the manometer. Hit the play button. That sounded expensive. All right, and then for my fan, I also want to make sure it's on the right setting. So I actually have it on E1 on the manometer, but it's set to E3 here, so I got to change that. All right, it's not getting a reading, so let's try E2. All right, still no reading, so let's try E3. All right, and it's saying 17 cubic feet per minute of airflow through our exhaust fan. I'll turn it back off. For bathrooms without a window, we want to have a minimum of 50 CFM fan installed. If it does have a window, we just need a minimum of 30 CFM. For a bathroom without a window, we want to have 50 CFM. Yeah, that would probably be best, yeah. All right, let's see. So that takes care of that section. Now we're on to the heating, cooling, and domestic hot water equipment. And and it makes it easier, right? My manometer is already turned on. So I don't have to worry about that later. Identify the basic heating or cooling system type, fuel, distribution, venting, right? So this is a forced warm air furnace, natural gas. It's ducted, obviously, if it's a furnace. And venting, it's an induced draft fan, atmospherically vented. Identify 3 basic heating system components. We have the cabinet. Back behind here, we've got our heat exchanger. And then down below, we have our blower motor. Identify the controls and how the set point controls the system cycling. Looks like we have our thermostat right around the corner. And so if we set our thermostat to 70 degrees, it's going to send a signal to the furnace. It's going to fire up and it's going to heat up the house until the thermostat is satisfied that we've reached that 70 degrees, then it will turn off again. Identify and describe 2 acceptable methods for temporarily disabling mechanical equipment. We've got our service switch right behind the corner, or we can do it, turn off the breaker at the electrical panel. Do a visual inspection of the flue system for the combustion appliance and identify and discuss concerns or problems. If no deficiencies, discuss one common concern or problem. So let me examine our flue piping real quick. I don't see any signs of rust or corrosion. One of the common defects would be the flue pipe itself is sort of back-picked, so it's sloped downwards. We always want to maintain that minimum 1/4 inch rise per foot. For the domestic hot water heater, identify the fuel source, that's natural gas. Appliance type, it's a tank. Venting, natural draft, atmospherically vented. And heating capacity, 30,000 BTUs. Identify 2 basic components and controls. Well, one basic component would be the tank. The second would be the thermostat. Describe how to control the domestic hot water temperature settings. Well, with the thermostat, we can rotate it clockwise to make the water hotter, or turn it counterclockwise to lower the temperature. Describe how to measure domestic hot water temperature. We can go to a nearby sink. We can fill up, let the hot water run, fill up a cup with water, and then use a thermometer to measure the temperature of the water. Identify the location of the pressure relief valve and drop pipe. And describe the condition of the water heater. Well, it looks like it was manufactured in August of 2024, so just over a year old. No signs of leaks, rust, corrosion, anything like that. Looks like it's in good condition. Describe opportunities for adding water heater insulation based on the nameplate or manufacturer's specifications. Well, the nameplate doesn't really mention anything here about insulation. I can see it's internally wrapped with insulation. We're inside conditioned space, so I wouldn't recommend adding insulation for this water heater. Identify and discuss opportunities for domestic hot water pipe insulation. Well, our water pipes are going up into the attic, so it'd be definitely worthwhile to insulate those hot water pipes to prevent wasted energy. Combustion safety testing. Discuss one common condition that can adversely affect baseline pressure differential measurement. Pinch toes or stepping on the hose. Discuss one common corrective action that can stabilize baseline pressure under adverse conditions. So if it's windy, we can do the time averaging on the manometer. Identify the specific location and boundaries of the CAS, and then the others. We only have the one CAS, so basically it's just this one small room. Set up the house for combustion safety testing in the CAS. All right, so now at this point, I can swap to my other paper. Prepare the house for worst case and natural conditions. For fireplace and wood stoves, it must be cold. Close the dampers. Put wet paper on any ashes. Close exterior doors and windows.
I'm gonna just get your video.
Yeah, I'm Spielberg for you guys.
I can tell.
Excuse me. All right, all windows and doors are closed. Open interior doors to rooms with returns, exhaust fans and clothes dryers. So this door, there's the bathroom exhaust fan that'll stay open. We've got our fake bedroom. It says supply only, so we would have that closed. Turn off all vented exhaust fans, clothes dryers, and other appliances. Bathroom fan's off. Kitchen fan is off. Dryer's off. For the clothes dryer, turn it off, clean the filter, inspect the outside vent for obstructions. I already did that with the exterior evaluation of the home. Filter's clean. Close all of the doors, turn off and seal AC windows and wall units. We don't have any of those. Turn off central AC and the whole house fan. Disregard roof vent fans, nothing to do there. Turn off the vented heaters. Set water heaters to pilot or turn off. Our water heater set to pilot. Let's turn off our service switch. The furnace, if the filter's dirty, replace or remove. Our filter's clean. Put it back. Let's see, I'm gonna go to the thermostat. I'm gonna set the fan to on and make sure it's off with the heating and cooling. All right, close doors to the combustion area zone. In the CAS, close supply registers, none here. Keep existing makeup air vents open. We don't have to do anything there. So let's get my manometer set up.
Salud.
Bless you.
Thank you.
I'm going to put the hose on the reference port. All right, so if you guys want to come in here, we'll close these doors. For the field exam, make sure the proctor's not going to close any doors for you, so you always have to close the doors. All right, so now the house is in our worst case depressurization, or in natural conditions, I should say. And so our first reading in natural conditions is negative 0.1 pascals. You can write that down. Turn on all vented exhaust fans and clothes dryers. I'm going to turn it to air only. Bathroom fan's on. Kitchen fan is on. All right, and the doors are closed again. I'll just wait a few seconds for the manometer to settle down. Looks like now we're at negative 0. Well, it changed a lot when you moved.
I wasn't.
You weren't stepping on it though.
No.
Right, so sometimes it's going to fluctuate a little bit. Just pick a number. So it looks like about negative 0.7.
Purposely standing backwards, so I don't step on it.
Now we'll turn on our air handler by using the service switch. This unit takes like 30 seconds to really fire up and turn on. Here it goes. Looks like a reading of about negative 1.2. So lastly, we'll open the CAS doors. With our CAS doors open, we're getting a reading of about negative 2.8. So that means worst case depressurization would be in this scenario with all the bathroom exhaust fans on, air handlers operating, CAS doors are running. So now we'll get ready for our spillage test. I'm going to turn the timer on but not start it. For the smoke pencil, go ahead and turn the light on so it's easier to see. All right, go ahead and fire up the water heater. I'm going to crank it up all the way, and I'm going to look through the viewing port just to make sure. Yep, flames on. Hit start. I'm just going to wait 15 or 20 seconds before even testing. Looks like the smoke's going up already. Checking the backside. Going right up. Make sure the proctor can get that on camera. Turn the light back off so we don't waste the battery. And so we pass spillage within 45 seconds. So the water heater, it passes. Next we're going to test for air-free CO, or carbon monoxide air-free, at 5 minutes. I'm going to get my combustion analyzer set up. Slid on down. Turn the backlight on. I'm going to scroll down, hit the down button 4 times until I get to carbon monoxide air-free at the very bottom. Hit the run button. Now while I'm waiting for that, completed item, my CO monitor says 0 parts per million. While I'm waiting for that to do its thing, I'm going to go to spillage action levels down below. So if spillage fails when the air handler's on, we want to seal ducts, resolve supply and return imbalances, or recommend service by a qualified professional. If it fails when the CAS door is closed but not when open, recommend measures to increase the air connection between the CAS and the house. And if it fails when the high exhaust from fans or appliances, but not from the air handler or CAS door position or a flue venting problem, verify sufficient combustion air according to ANSI Z223.1, NFPA 54 for gas, or NFPA 31 for oil. Recommend service by a qualified professional. If spillage fails, retest spillage in natural conditions. And if spillage and CO fail, strongly advise the homeowner to turn the unit off and get a service by a qualified professional. If we were to test a second appliance after the water heater, so we would wait until we've tested this for CO at 5 minutes. We would turn the furnace on. At 2 minutes, we would go back to our first appliance and retest it for spillage. Immediately thereafter, we'll test our furnace for spillage. And then at 5 minutes, we're going to test with our combustion analyzer for carbon monoxide air-free right at 5 minutes. Well, it's been 3 minutes now. Oh, interesting. We're not putting any numbers here either. This is a different one. There, that was going all right. Now it stops. All right, so we've got a little connection issue here too. It's like when I'm holding it, it's showing it. When I put it back, it's just showing asterisks. So I'll just hold it. And so we'll just say it's been 5 minutes. It's just an exam. It says 36 parts per million. Our CO limits and actions for combustion appliances for a central furnace, boiler, or clothes dryer, it's 400 parts per million, CO air-free. Water heater, room heater, or wall BIV furnace, it's 200 parts per million, CO air-free. Oven or broiler, 225 parts per million, CO as measured. a gas log and a wood-burning fireplace, 400 parts per million CO, air-free and firebox, and a gas log or a gas fireplace or a propane refrigerator, the threshold is 25 parts per million CO as measured in the vent. If CO fails, notify the homeowner to have it serviced by a qualified professional. Now that testing is complete, the first thing we do is turn our water heater back to the pilot setting. That's a gated item. Turn our air handler off. Turn off these other tools. Turn off the dryer. Turn off the big bathroom and kitchen exhaust fans. Then I just want to go back to this page here real quick. I want to make sure I didn't miss anything. At number 4, right, we got the house set up for our testing, measured the baseline, turned on all our appliances, did the furnace, we did all that CAS stuff. Right, it says number 11, spillage, identify the smallest input BTU appliance, and if the vent is warm or cold. Well, I guess I didn't mention that. So right, this one it says 30,000 BTUs. This one over here is 40,000 BTUs, so this is the smaller appliance. The water heater is always considered a warm vent.
You went back?
Yes, this is number 11 on the main guide. Yep. And everything else there was done, so it was just that one item that I overlooked. And then number 10, discuss 3 potential sources of carbon monoxide in the home: water heater, furnace, oven. We already did number 2, 3, and 4. And discuss the procedure for measuring carbon monoxide in direct vented and power vented combustion appliances. So that would be with a PVC vent, right? That's going to go to the outside of the home. So if I can safely access where the vent terminates for the combustion analyzer, I'll just stick the probe right down the flue vent. If it's someplace where I can't get to, if it's up high, like on a 3rd floor, or like in an attic, or a roof, I won't be able to test it due to safety reasons. Bless you. Oh, that's funny. It's like I heard a noise. I thought I turned everything off, but something out there. All right, so now we're on to page 11, blower door testing. Identify 2 potential hazards or circumstances that would prohibit conducting a blower door test if there was mold or if there was asbestos. Identify the conditioned space of the test house. Well, it consists of this dryer, this CAS, this other random room here, and our kitchen. We've got our fake garage, it doesn't include that. For one room, measure and calculate both the floor area and the volume. A nice easy room here. About 5.5 feet. That's annoying. About 8 feet. 5.5 times 8. Get my calculator out. Is 44, and then we want to find the volume. So now we need to get the height. That's 7.5. So 44 times 7.5. So the volume of the house of that room is 330 cubic feet. Let's see. Describe the difference between blower door pressurization and depressurization. Well, for a pressurization test, the fan is blowing air into the room, so we're pressurizing the house. And for a depressurization test, right, the fan is sucking air out of the house, so we're depressurizing the home. Explain the difference in blower door equipment setup for depressurization versus pressurization. Well, for the manometer, the hoses are basically the same, but you just want to follow their completely blanked, whatever their quick guide for setting it up. For the fan, that's the primary thing. Some fans have a little switch that'll change the direction of the airflow, or if it doesn't have that, you just have to turn the fan around. Gated item number 6, for all vented appliances, turn off or set to pilot or set to standby to ensure they don't fire during the blower door test. Well, I've already got off of the service switch and just verifying again that we're set to pilot light for the water heater. Verify that solid fuel combustion appliances are an appropriate setup for the blower door testing. If none, describe the appropriate conditions. I said that earlier. If there was like a wood fireplace, obviously we can't have any warm ashes or an active fire. We have to delay the test. So if there's ashes in the fireplace, we want to either clean it out, put a wet towel or newspaper over it, make sure the flue is closed. Set up the house for blower door testing in accordance with one of the approved methods listed in ANSI BPI 1200. So at that point, right, it's just time to set up our blower door test and drink some water. Any questions so far?
Oh, you gonna do the 2-foot method?
1 foot, 1 hand method. Uh-oh.
It's like the logo always facing up.
Logo's always facing up. Velcro's facing up. My green hose. I want to make sure it's out of the path of the fan flow, so it's going to be off to the side at least 5 feet away. All right, then I'll lock the frame in place. Bring the green hose through the bottom slot or opening. Set up the support bar on the lowest rung. Tighten the knob, extend the lever. Set the bottom of the fan first. All right, fan secured. Hook up the fan power supply. Make sure the rocker switch is off. The little fan speed controller is down to the bottom. Plug in our fan. My manometer's already turned on from before, but I'm gonna go back to home. Tubing assistant, building tightness, basically select everything on the left. Depressurize, inside the building, model 310 volt fan, or model 3 110 volt fan, continue. Red hose goes to the fan. Green hose to the outside. Hit the play button. And now, because stuff happens and weird things happen sometimes, let's just make sure my blower door is good. That's pretty secure. And just make sure that all the windows are closed. Oh, like this one. All right, windows and doors are still closed. All the fans are off. Water heater set to pilot. Hey, wow, I just checked that a third time. It's pretty good. All right, we're gonna set our baseline reading. Out in the field, if it's a windy day, maybe we'll wait up to 30 seconds to get our baseline reading. Since this is just a testing environment, we'll just say it's been 30 seconds. Hit enter. Let's see, we've got open fan here, but for this house, we know we want to have ring A on it, so change it on the manometer. Almost forgot that, my cruise control. All right, rocker switch is on. Play button. All right, so our blower door CFM reading at minus 50 pascals is about 1580 CFM. 2 sources of air leakage in the building in 2 different rooms. Attic access, we have some air leakage in that room. Around this receptacle on the wall in that room. We want to test one item that is not a duct. Test that just regular. Alright, I'll take this close. Oh, there we go. Alright, it has a reading of jumping a little bit, but minus 22 pascals. Right, we want it as close to 0 as possible, which means air sealant is needed in this area. We'll check one area that is a duct. I have a reading of about minus 6 pascals. Anything over 3 pascals, we want to recommend air duct sealing. Our zonal pressure diagnostics. I'll go to our ceiling. I want to check out the pressure differences between the attic and the living space. And typically, we want it to be as close to 50 pascals as possible. So if it's over 45 pascals, then air sealant isn't really needed. So this is at 47 pascals, so I wouldn't recommend additional air sealing. All right, I've stopped the fan, but I'm not going to worry about tearing it down at the moment. All right, so I completed the blower door stuff. Let's see, the blower door running, did the infiltration in 2 different rooms, used the pressure pan, that's for an area that's not duct work, tested 1 duct, did the zonal pressure differential between the conditioned and unconditioned space. Now we're on to the HVAC distribution. I already identified the distribution system type and talked about the insulation. Identify 1 supply duct and 1 return duct. There's the supply. And right around the corner there on the floor is our return. Or if they want the duct itself, right, there's the return duct. To determine the location and condition of the filter, right, the filter's located right there. We had checked it earlier, it's in good condition. Measure the size of one supply register and one return grill. So come over to this one. Our supply register is about 10 inches by 4 inches. And then our return grill size is about 20 inches by 15. With only the furnace blower running, before room-to-room pressure differential diagnostics between two spaces within the house. All right, so for that, I just want to put the cover back on my blower door. For this test, we want to have all the doors and windows closed still. Let's see. Turn our air handler on. This time I'm going to put it on the input port and slide our hose under the door. Close our door. Air handler just kicked on, so we'll wait wait a minute for this one. It's also helpful to remember that in this small dryer room or laundry room, we only have a supply duct in there. Right, so if this door is closed, right, there's no, no return air being sucked back through. So I know that room is going to be pressurized. So that sort of helps me do the exam, right? So it's saying, hey, that's about 6.3 pascals of pressure, right? So anything greater than 3, we want to try to, eliminate that pressure difference. We want it to be as close to 0 as possible. So we can either undercut the door, we can add a return air duct or a jumper duct. Number 7, 2 conditions that can impact the performance of supply air. If the register is blocked or if the damper is closed. 2 conditions that can impact the performance of return air. If the duct is blocked or the filter is dirty. 2 conditions that can impact the performance of hydronic baseboard heating. If the aluminum fins are damaged or if they're covered with cat hair. 3 potential negative impacts when the distribution system is located outside the thermal envelope. Comfort problems, ice dams, and energy loss. Discuss 1 purpose of duct pressurization testing to determine the total amount of cubic feet per minute of air loss in the duct system. Appliances and lighting, locate a manufacturer's nameplate on 1 major electric appliance. All right, so I know that's going to be over here. I'm going to get my camera out for this part. It's a little difficult to get down low to see the label. It's a dehumidifier, right? So the manufacturer is Electrolux Home Products. Let's see, model number FAD301NWDA, serial number KN801000917, and the capacity 30 pints per day. Discuss 2 topics to ask a homeowner about the operation of their lighting and appliances. Well, how often do you leave your lights on? And how often do you use any room air conditioners, window units? Describe where to find the wattage rating on different light bulbs. For CFL and LED, it's on like the base or the neck of the bulb, and for incandescents, it's on like the bulb end of the bulb, the top end. Describe how to determine the total wattage of lighting in a room. You have to discover the wattage rating for each light bulb and add them all together. 14, baseload, renewables, and water conservation. Describe the difference between baseload and seasonal energy use. Well, baseload is for those appliances and electrical loads that are used throughout the year. Seasonal energy use is for those appliances that are only used a part time of the year. Provide 2 factors or examples to determine baseload. That would be like the water heater and lighting. 2 examples of seasonal energy use would be heating system and Christmas lights. 1 method or source used to determine the electrical consumption of appliances would be the kilowatt hour monitor. Describe 1 method to determine water flow rates for faucets and shower heads. Most of the time they're going to have that listed right on the fixture itself, where you can look at the packaging. Identify 1 renewable energy source and its related equipment. If none, describe 2 components found in a renewable energy system, solar panels and an inverter. Now we're ready for the oven test last. So we need our combustion analyzer again. And look at that, I actually made a stupid mistake. I turned off my combustion analyzer. Well, you gotta turn it on that side again. First, we want to inspect the oven, right? Remove all items and foil from the oven and broiler. Let's open it up. Oh, sure enough, look at that, there's a bacon pan. Identify and discuss concerns about excessive debris inside the oven. Just if there's a lot of debris inside the oven, it's going to lead to higher CO. So we'd want to have the homeowner get that cleaned out before we test it, if possible. Describe the testing procedure for a gas oven, and after 5 minutes, measure and state the CO level on the vent. Great, so we're going to do bake. We're going to set it to 500. Start. We're going to turn on our timer and start our timer. So we want to test for carbon monoxide as measured at 5 minutes. For this part too, since we do have some CO buildup that occurs inside the home, let's just open up a window, open up a door. We're not here to injure ourselves. All right. My combustion analyzer is operating again. We're going to stick it in the throat, turn our backlight on. And again, for this one, we're doing CO as measured. So we're not scrolling down the 4 to get to the CO air free. We're doing that second option, just regular CO. Gonna hit the run button. Right now we're at 1 minute and 15 seconds. When we get to 5 minutes, we'll give off our carbon monoxide as measured reading. And then it says identify the action level for oven CO and interpret the results. Well, I already said that earlier, but it just takes a second to look again. It says for the oven or broiler, the threshold is 225 parts per million CO as measured. If CO fails, notify a homeowner to have it serviced by a qualified professional. So then the last thing is just when it gets to 5 minutes, just to give off the CO reading. Included everything. If you want to take a minute or two just to look through everything again, make sure you didn't skip something simple. Great, you can do that. Or at the very end, it's great, that's the end of my exam. Then the proctor's going to read off something like, hey, it's my understanding that you've completed the exam. Hand over any paper you've used for the exam, that sort of thing, and then and that's it.